Okay. All righty, so that was this particular problem. So does that make sense to do it that way? When there's multiple steps, you've got to abide by order of operation. So that's what rules. This second one had to do, I've seen the problem. I'm going to do one later with a third off. But if you're taking a fifth off, you're really taking 1/5 of this. And so 1/5 of 52.99 is what you're trying to do. And you could actually do it this way. You could just say 1/5 of that number. And so of between two numbers means multiply. So what it amounts to is 52.99 divided by 5. This is one way to do it. This is not the only way. And so at this point in time, you would divide it. Okay, I know there's another way. So I'm going to just quickly do this. This is 1. When you bring the 2 down, 5 doesn't go into 2, so you say 0. You bring the first 9 down. 5 into 29 is 5. And this is 25. When you reduce this, this is 4. Bring down the 9. So 5 into 49.
This pattern.
Yes. Go ahead.
It's frozen for me. Oh, okay, there you go. It's just slow.
Yeah. So, okay, so 5 into 49 would be 9. 9 times 5 is 45. 4 is left over. So you might think the answer, and this is how much you're going to take off, by the way. This is not the price. It's not going to be $10. So what we need, let's see. So this, if I go one more 0, 5 into 40 is 8. And so that would be the answer. So they're going to take that much off the price. There may be a rounding error here, depending on how this goes. This would round to the nearest penny. The 59 with an 8 after it would be $10.60 off. Right? So this is the 1/5 is how much is off. So they're going to take off $10. That kind of makes sense. $52.99 minus $10.60. So this is what I'm coming up. I took 1/5 off. I subtracted it off of the regular price. And this should be the sale price. Now, I don't know if that worked or not. That is one approach. And I use that approach 1/5. If you divide it out into a decimal, 5 into 10 is 2. And then 5 into 0 is 0. So 1/5 as a decimal is 0.20. At this point in time, you could have done this problem the other way. 1/5 off would be 0.20 multiplied by 52.99. So this is 1/5 as a decimal. And when you multiply this out, you will get $10.60. And this is still the amount off. So this was the other approach. Now, sometimes fractions work better than decimals. And this is why they offer you both ways to do it. And this, of course, is how much is off. This is not the price. You then have to subtract it from the price, and then you see what your sale price is. Any question? Does that work?
Mm-hmm. See, I was getting confused because of the fact that when I would, excuse me, I don't know everybody, but when I did it, it would have like a different. So I would get the sum of say this, but then it was like, I don't know, 52.90 would be 42.99, and it didn't have a 60 in it. Like it was weird. I don't know. Some of the answers I was putting.
It depends on what they ask for. So if they say, how much did they, the amount that they took off?
The sum. Okay,
And
so
it
I know
would
it's
have to have
40.
been this
I forgot
number.
exactly the equation itself, or excuse me, my answer, but it was saying it was 52.99 minus, just say it was minus 10, right?
Yeah.
Or no, that wouldn't work. Say it was minus 10.20, so it would be like 42.50. Mind you, I'm just throwing numbers out there.
Yeah.
But so I had a totally different sum, and the first time I put it, I was wrong, and then I put 42.99. I don't know if because I think they were rounding it up at the end, and
There
even though it
is
was
a
like 20 off,
possibility. Yeah, there
even
is
though it was
that
20 off, it
possibility
was
of
right.
rounding. Because we rounded this part of it. And then, so we, I still think this is probably the exactly right answer to the penny. But we did have to round here. And so that's why I'm a little bit concerned. But if you can find the exact numbers on your problem, how much was off, and we can do that when we do all the other problems. But did this pretty much work?
It does, but I came up with the same issue where I came up with 42.40 as my final answer.
Did they mark it wrong?
And the computer said it was wrong. And there was no video attached either.
Yeah.
And when you did it, it was like,
yeah,
did you play
I think
with
this would have worked.
Did you play with the
I
decimal?
think this was the difference, the penny.
Because it would be like 42.40, but then I put like, it would either be like 42.41 or like 42.38. It wasn't the right answer. It was either down or up a decimal. It's weird.
Yeah. This is the advantage of me grading your work. You see what I'm saying?
Yes.
I can see how you approached it. Now, this is one approach, but I can see with this rounding, I mean, here's the truth, and I don't want to waste too much time on this, but when they subtract a fifth, they actually leave 4/5 of the price. And so there's multiple ways to do this and get your final answer. And so it may result in a penny off, depending on that approach. Okay. And so, but this was a legitimate way. This was a perfectly good way, and that's why you want me to look at your work. Okay. Let me do this last one, and then I'm going to go to the last section. We want this as a fraction, and this is quite a big fraction. This is tenths, hundredths, thousandths, 10,000ths. So you would have to have 6875 over 10,000. 1, 2, 3, 4. Notice it has 1, 2, 3, 4 zeros. But you've got to reduce that. And so you can either reduce it by 5 or by 25. And so if you're more comfortable with reducing by 5, every time you reduce it, it's going to be a lot better. And so I'm going to start with 5, although I can reduce it by 25, but 6875 divided by 5. Let's start cutting this down. So 5 into 6 is 1. Bring down the 8. 5 into 18 is 3. This is 15. Bring down the 7. 5 into 37 is 7. 35. Almost. One more. 5 into 25 is 5. So when I divide 5 into this, I get 1375. And 5 into this number, I can do in my head. 5 into 10 is 2 with 3 zeros. So 5 into 10 is 2000. And that's what you're going to have to do is keep going. This is smaller, but not anywhere near done. I'm going to take my 1375 by 5, and I'm hoping for a much better number. 5 into 13 is 2. Subtract 3, 37. 5 into 37 is 7. You know what I'm doing here. And then finally, 5 into 25 is 5. So 5 into this number is 275. 5 into this number, I can again do it in my head. 5 into 20 is 4 with 2 zeros. And you just keep going. Now it's getting much better, but it's not done, is it? Why? Because this still has a 5, this still has a 0. That means 5 will still divide it. So I'm going to divide 5 into that. 275 divided by 5. We're starting to get there. This is 25. Oh yeah, 5 into 25 is 5. So this would be 55, and 5 into 40 is 8 with 1 0. I think one more will do it. 5 into 55 is 11. 5 into 8 is 1, 3 left over. 5 into 30 is 6. Oh my gosh. So I think we had to go at it 4 or 5 times. It's because the number was so big to start with. And if you could see this in terms of 25, if you thought of this in quarters, but I think maybe just doing it by 5s and be super careful. Did that help, Lamont?
Yes, I guess just such a long process, just.
There was no way around it. When I saw that big number, I knew we were in trouble.
Yeah,
Okay.
thank you.
Yeah, but dividing by 5 is not as bad as some things.
Mhm.
So what I want to do next, I want to do 4.6. And this is about square roots. And the interesting thing, well, I always like old classic movies. Okay. This idea comes up in an old classic movie about this is the Pythagorean theorem. And so what it amounts to is these two of the sides are perpendicular to each other. In other words, they form a 90-degree angle. And so they literally have, usually when they start it, they call the two sides next to the right angle are A and B, and they might call this one C. Now the side C is called the hypotenuse, but it's always the longest side. It's the side across from that. So there's a little formula that somebody figured out. The person's name was Pythagoras, Greek. And so the little formula goes A squared and B squared equals C squared. Now the movie where this comes in is The Wizard of Oz. So you remember she's trying to find a way home. And so she goes to see the wizard. And the scarecrow, I think, wants brains. And as soon as the wizard say, oh, here you go, the scarecrow starts talking about this long formula to show how smart he is. And the long formula is a long way to say this, the Pythagorean. If the sum of the squares of the sides of a right triangle, la, 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 and it goes on and on. He says it really, really fast. And so you're not really sure what it is. What he's saying is the Pythagorean theorem. And so this worked in all kinds of situations where you can measure two of the sides, but you can't measure the third side. And so they use it in surveying and all kinds of things. But I love it when math creeps into a movie. Somebody's like, I think I'll do that. So anyway, it sort of fits with the whole thing. But I want to do a problem and show you it requires one angle to be 90 degrees. And I think it's vertical and horizontal. And so I'm going to make this side 3 and this side 4 and this side, we don't know. So knowing that the two smaller sides and the two smaller sides are the sides here, this is the longest side. This would be 3 squared and 4 squared would have to be the letter C, which is a number, squared. And I can do a lot with this, but I'm not going to. But 3 squared is 9. 4 squared is 16. And together that makes the answer squared. So now I'm going to, this is a little equation, but we can do it. 9 and 16 is 25. You see where this is going? So my answer is not 25. It's my answer squared is 25. And so in order to figure out the value of C, not C squared, who cares about C squared? I want C. What you end up doing is square rooting both sides. And so you square root this and you get C, and you square root this and you get square root of 25. And the problem is, what number times itself gives you 25? This is a perfect square.
5.
It's a 5. It's not 5 times 5. It's just plain 5. And so the square root of 25 is 5. And the problems in this book that we're studying are all what I call perfect squares. So the square root of 16, and there's a lot that numbers that are not perfect, but the ones that we talk with mostly are perfect squares. The square root of 16 is 4, because 4 times 4, the square root of 9
Is 3.
3. So everything you can do mathematically, there's got to be a way to undo it. So when we did a power like 3 squared, 3 times 3 is 9. There's got to be a way to undo it. I mean, really, there's got to be the back and forth. It's just like adding and subtracting, multiplying and dividing. There's the opposites. And so the square root of 100,
10.
10. And I'm going to do this weird one. The square root of 1 is 1, because 1 times 1 is 1. The square root of 4 is 2. Do you see how this is going? So these are perfect squares. And for this particular formula, you're going to end up not only, you're going to end up with the value you want squared. And so what you have to do is then square root it. But fortunately, they're giving you decent problems. And the interesting part about square roots is this, and just to show you briefly, if the square root of 4 is 2, and the square root of 9 is 3, right? The square root of 5 is what? Well, it's not a lovely number. It's one of those numbers, a decimal number that goes out forever. And so there's not a nice way to do this. And so you pull out your calculator and you do square root of 5 and you get a number like, I don't know what. Let me see what it gives me. Square root of 5. 2.2360, blah, 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 blah. And so when the answer does not come out a perfect square, this number goes forever. It never stops. And so what you have to do is, well, how much do I need? Do I need a couple, 2 decimal places? Do I need it rounded to 3 decimal places? Whatever, and I just use that number. But fortunately, most of our work is with perfect squares, and perfect squares you can do in your head, okay? So let's see, they've given you formulas for how to do this, but I'm of the opinion, let's do a few little things. So they start out by just having you play games with square roots. And so if you recognize 64 as a perfect square, what is it? What is 64?
8.
This is 8. And there's absolutely nothing between the 7 and this. So you have to interpret it as multiply. So 7 times 8 would be 56. So they play a few games like that. Here's another game they play, the square root of 25 over 81. This, you can do it individually as well, the square root of 25 and then the square root of 81, or you could have just pulled the answer from here. But this is what you're thinking. The square root of 25 happens to be 5. The square root of 81, I hope you recognize it, would be
9.
9. And so this is not as simple as possible. This is better, 5 over 9. And so that's what they expect you to do with it. And so there are several little problems like that. But the interesting ones, let's see, let me see if I can find something else. See, we understand order of operation. And square roots are in the same category as exponents. And so they have to be taken care of first. Remember, subtraction is last, unless there's parentheses. So square root of 25 would happen to be 5. The square root of 4 would happen to be 2. And then you're allowed to subtract. 5 take away 2 is 3. So I don't think that's a big deal, do you?
Mhm.
Nah. Okay. And if it's not a perfect square, you've got to get a calculator. That's all there is to it. So this one's 6 and this one's 8 and this one is C. Okay. So you can either consult the movie or you could write down the formula. A squared plus B squared equals C squared. And the two shorter sides have to be together and the long side has to be by itself or it won't add correctly. So either one of these could be A or B. They're interchangeable. And so I'm going to just take them as I see them. 6 squared and 8 squared makes C squared. Okay. 6 squared, we know, 36. Adding as last. 8 squared, 64. And that's going to equal C squared. So 36, what? And 64
100.
make 100. Okay,
So 10.
not done. We have the value for C squared, but nobody wants that. They want C. So we square root, and I'm doing this slightly different than the book, but I think this is clearer. The square root of 100. I'm square rooting this side as well, by the way, to get C, but I'm square rooting my 100. And so what do you say? We did it a minute ago. What is it? Square root of 100 is
10.
10. Done. Okay. Now, if for some stupid reason it's not a perfect square, and I'm seeing one right now, and I know it's not a perfect square. So this again, even though I've turned the triangle around, nobody cares. This one is 2. This one is 10. And this one, they call it A. Can you see how this is slightly different? It's slightly different because they gave you the long side. So I'm still going to write down my formula. A squared and B squared is C squared. And they were nice enough to call this A, so I'm just going to copy it. This would have to be B. this would have to be C in my formula. So B would be 2 squared and C would have to be 10 squared. So I want you to stop a minute and see if that's clear. That's my window. There. Okay. So very clearly the 10 had to be C because it's the longest side, this side across from the 90 degree. This little mark is used in geometry for 90 degrees. And so A was missing. B had to be this little other side. These are called the legs, by the way. And C, the long side, was 10. So now I'm going to try to solve this. A squared plus 2 squared is 2 times 2, 4. 10 squared. 10 times 10, just reverse of what we did, is 100. I'm getting a signal. My internet is unstable.
Yeah, you're cutting out.
I know, that's, yeah. I want to subtract the 4 here from each side, just real quick, to make it 96. And A squared is 96. It's kind of windy where I am. What would then the answer be? A would equal square root of 96. What would you have to do to solve that? Is that a perfect square, 96?
No.
No, you'd have to use a calculator. And I'm not going to test problems like that it forces you to use a calculator. But can you see that? I did do a little tiny bit of algebra. Does this make sense that I subtracted the 4 so I could see what was left? And it's the square root of 96. And so I wanted to just show that you may run into a problem or two where they're expecting you to use a calculator. I'm not going to test it, but you might see it. But if I pulled out my see if I can see it. Answer was 9.79795. Okay, that's my calculator answer. If they said round it to hundredths, what would the answer be? 9.8.
9.8.
9.8. Because they said hundredths, you could include that 0 just to show you took it to the hundredths, but this is also correct. This is also correct. But I wanted you to see that. So I wouldn't fret about problems. The book provides formulas that is not using this Pythagorean theorem formula. I mean, we can do it that way, but I think in the end, it's the Pythagorean theorem formula. The book provides 2 formulas, and I think that adds to the confusion. C is the square root. This is what it's providing. It's really the same formula, by the way. They're just doing it all for you. So all you have to do is put in A and put in B. So the problem, and I don't know if this is this problem I did, this one. So you would go square root of 3 squared and 4 squared. Do you like this better? Like that. Anybody have an opinion?
It's okay.
So that's definitely a formula. And then the other one, if one side was missing, and this is what they do, So that's the formula they provide. And so doing a similar problem, let's make this A, make this 8, and make this 10. Okay. So if A was missing, it's one of the legs, it's one of the shorter sides. This would be the formula they had. This would have to be C. By default, this would be B. So A, B, and C, the long side. So this would be 10 squared minus 8 squared. 10 squared is 100. 8 squared is 64. 100 take away 64 is 36. The square root of 36 is 6. So this particular missing side, when it was one of the two shorter sides, the answer turned out to be 6. And you can use those two formulas if one of them is missing. I don't know if that's more confusing or not. I'm not sure. But I wanted you to see at least two approaches. Does anybody have a question on that? Because somebody may have done it this way using their formula. But the truth of the matter is that it all boils down to this. A squared plus B squared equals C squared. And so if you only have to remember one little thing, and I'm into like, I don't want to remember 5 things. I want to remember one. This is the one thing that will take care of any problem like this, where you have 2 out of the 3 sides, and you can clearly see which one is the longest side, and that has to go all by itself on this side, the other 2 on the other side. Okay. Anybody have a question right now? Just turn on your mic if you do. Nobody's talking. All right. Here's what I'm going to do. What I'd like to do is do some problems. There's some practice work at the end of unit 3. I think probably you know where it is. And I pulled some problems from that. And so I'm going to quickly review as much as I can. If you're going to add or subtract fractions, you must have a common denominator. And the quickest way, since these numbers are fairly nice, would be to take the 50 and do multiples. 50 is not big enough for both of them, but 50 times 2 is 100, and I would just go with that one. Does that work for you? So 50 times 2, and it would be 2 over 2 is 100. So 1 times 2 is 2. So that's equivalent. And as far as 20 is concerned, we did this work with this earlier, 20 times 5. So 1 times 5 is 5. At this point in time, don't forget that this was a subtract problem. And so 5 take away 2 is 3 over 100. That is reduced. Okay, so the point was it's subtract or add. You had to have common denominators. And I'm going to do one that's a little bit harder. If you ever have a harder problem where finding the common denominator is not so simple, like the previous one, probably your best bet is prime numbers. And so I'm going to show one of those. So here's 18 and here's 27. And what I'm going to do is break them both down so that I can see what numbers are inside. And so the prime numbers are 2 and 3, and I'm not going to need much more than that. 2 into 18 is 9, right? 3 into 9 is 3. So 18 is 2 and a 3 and a 3. 27 is made up of threes. This is not even, so I'm going to try 3, and it does go. 3 into 27 is 9. 3 into 9 is 3. So 27 is 3 times 3 times 3. When I can see what I'm working with, I can get the perfect common denominator and the lowest. And so lowest common denominator or least common multiple, as far as 2s are concerned, I only have 1. But as far as 3s are concerned, I have 2 here and 3 here. I have to take the number that has the most. That would be the bottom one. I don't need all of this. I just need the most of each type number. And so this one, this was 27. 27 times 2 is 54. That's my number. I don't know if that was obvious to you. It wasn't completely obvious to me. And so that's what I'm going to do. This is 54. And this has to be 54. That's the best you can do. 27, we just did it a second ago. It's 27 times 2 is 54. And 2 times 2 is 4. So that one's done. Now with the 18 times what is 54? I want to show you this again. 18 was 2, 3, and 3. So this much is 18. A 2, a 3, and a 3. The missing factor in the total 54 is an additional 3. So you could divide 18 into 54, but guess what you're going to get? You're going to get 3. Because we know what 54 looks like. It's 2, 3, 3, 3. And so now I'm ready to go. 7 times 3 is 21. I can now add this. 21 and 4, 25 over 54. And because we know primes, 25 is 5 times 5. There are no 5s in 54. Remember what 54 looked like? 2 and a couple of 3s. So there's no 5s in it. We know that for a fact. What that means is this problem is complete. Okay. I'm going to keep rolling here. I noticed this in the practice. This is an interesting one because order of operations says to add first. And when you add first, you don't have common denominators. So you have to get a common denominator. But there's another way you could do this, which would be slightly easier, and it's the distributive property. So let's look at what that would be. If we multiplied 15 times 4/5, and then we multiplied 15 times 1/3, I'm going to put 15 over 1. Notice what happens. These cancel, which avoids the necessity of making common denominators and doing all that. 5 into 5 once, 5 into 15 3 times. So 3 times 4, yep.
I'm a little lost there.
Yeah, 5 into 15, I lost my internet there.
Right.
5 into 15, 5 into 5 once, 5 into 15 3 times, 3 times 4 is 12. That's good. This will cancel as well by 3.
Oh, I got it. Okay.
3 into 3, 1, 3 into 15, 5, 5 times 1 is 5. The answer is 17. So you could have done it the other way, but when I noticed that the 5 would cancel with 15 and 5 and 15 with 3, I said, darn, I think I'll use the distributive property. And you know, here's the next one. Find the sum of these 3 numbers. Okay. Sum means add. I'm going to line them up vertically so I can see them very carefully. This is 4/5. I'm going to put my 2 next, and I'm going to put my 1/2 next. And I'm going to say add. And so clearly adding the whole number 2 is not the problem. Adding the fractions is where you have to work, right? Common denominator would be 10. I think that's fairly clear. I'm going to double this. 4 times 2 is 8/10. 1/2, I need to multiply by 5. 1 times 5 is 5. So what happens is I end up with a 2 because I don't want to forget it. And then when I add this, 8 and 5 is 13/10. They are not going to accept that answer. You know that, don't you? Because 13/10, they call it improper, but it's basically just not clear. 13 divided by 10 as a mixed number is 1 3/10. And this is 2. So the better answer would be to convert this to a mixed number, 1 3/10, add it to the 2 that was already there, and you get 3 3/10. So I would expect you to do this. This is deceiving. It looks like it's 2 and change, and it's not. It's really over 3. And so this is the better answer. It's clearer. Okay. Let's see. The next problem involves mixed numbers. Remember, adding is last, unless there's parentheses somewhere to force you to do it sooner. These two numbers need to be multiplied first. And to do multiplication, you don't need common denominators, you just need simple fractions. So 4 times 2 is 8 and 1 is 9. 9/4 would be just fine. This one here, 3 times 5 is 15 and 1 is 16. This is 16/3. I can reduce this really nicely. Can you see it? I can reduce the 3 with the 9. So 3 goes into 3 once and into 9 3 times. How about the 4 and the 16? 4 goes into 4 once and into 16 4 times. When I cancel the problem,
It is moving off a lot, and so we're taking time to like take notes, and so I don't know, it's just taking too much time to.
Oh, I'm going too fast? Is that what you're saying? I'm going too fast?
You're going too fast, and then for some reason it's starting to freeze off. So pretty much you just did the problem, and then when you were like explaining the process, it didn't work, and it's just taking forever.
Okay, all righty. So I guess I'm gonna just have to slow down. I was looking at the time. So, all righty. So what I did was I made these mixed number or improper fractions, simple fractions. And then I saw the good opportunity for canceling. Do you see that? The 9 and the 3. And then I also saw this other good opportunity for 4 and 16.
Yes.
And when I canceled it, 3 times 4 is 12. At the very, very end, I add. And so then my final answer would be 15. Okay? So this had add, but it also had multiply. And the multiplication is done before the adding. And so we just said, okay. Mhm. Someone asked me about this problem. Subtract 6/7 with a problem similar from the product of 2 and 2 2/5. Okay? Subtract is subtract. Product is multiply. And when you subtract from, this is first. So the first thing I have to do is multiply. And so I need to multiply 2 times 2 2/5. When I do that, I will subtract the 6 7s. So this is the same deal. This requires you make it a fraction. Same thing, make it a fraction. 10 and 2 is 12 over 5. Okay? You look to see if anything will cancel, but it doesn't. So here's what I'm going to do. 2 times 12 is 24 over 5. Now I've got to do the subtracting, and I'm going to write it vertically. And I may just leave this. It's not too big. I think I'm going to leave it. 24 over 5 minus 6 over 7. So what I did was, this was my answer for the multiplication. I decided to leave it and try it. 24 over 5 divided by, or subtract 3 over 7. I think we can
Can
make
you
this
go
work.
back to the answer, the work that you just did, because it froze and then I didn't have time to write it down.
This one?
Yes, thank you.
Okay.
Okay, yeah, that's fine. Thank you.
Okay, so sometimes we make this a mixed number. I decided, since it's not so big, I'm just going to leave it, because I know occasionally somebody does that. The common denominator, of course, is 35. I'm going to have to multiply. This is the problem with not making it a mixed number. I'm going to have to multiply by 7. 5 times 7 is 35. 24 times 7, I'm going to do it on the side for you, is 168. This is the problem of leaving things without making it a mixed number, but I'm going to do it anyway. This one here, 7 times what? It's got to be 7 times 5 is 35. 6 times 5 is 30. This has to be subtracted. 168 take away 30 would be 138 divided by 35. At this point in time, I think they expect you to make it a mixed number. And so you either pay at the beginning or later. 38. I think it's 3. Yeah, I think it's 3. 15 carry a 1, 9 and 1 is 10. When I subtract, yeah, it was very close, wasn't it? There's my internet. I understand it cuts off. But I did this division. I have a remainder of 33. So this 3 and 33 over 35.
Ms. Patterson, if we
Yeah.
have something important to do, is it okay if we leave?
Say again?
Yeah, I have something really important I have to attend to. Is it okay
Okay,
if I
go
leave?
ahead. Yeah. So you can watch this again. That's the thing about it. Watch it again because it's recorded. So
Okay.
if you need to go, that's fine.
All right, thank you.
And so the other thing, and I can stop here or I can do a few more. What do you think? Nobody's talking.
Be nice if you did more.
Okay, I'm gonna do a few more. Let's go into the decimals, and then if you need to leave, go right ahead. Here's decimals, round. Here's my number, 0.8042, okay? So what if they said round it to the ones, the whole number? What would that be? Where is the, which number is the whole number? It's not the decimals,
It's not the 0.
it's this one. Can we round to that place? We can, because we look at the very next number to decide what happens. Because it's 8, what happens to the 0? It goes up 1, doesn't it? In other
You're
words,
totally correct.
it goes up from 0 to 1. I thought that was kind of weird. That's why I wanted to show it to you. But think of this as money. I like money, okay? This is 80 cents.
Yeah.
Round it to the nearest dollar. $1, right?
Yes.
Yeah. Let's do the next one. Round to the nearest tenth. Now the 10th place is this one. What's your answer? 0 point. What does this 0 do to us? It's not very big.
No, nothing.
You just copy the 8. Okay. Round to the hundredths. I think we're overloaded here. Round to the nearest hundredth place. So I'm going to write it again. 8042. Tenths, hundredths. Your answer is this big enough to push this up?
No.
No. So your answer is 0.8.
8.
Yeah.
Or
And there
8.
is a tendency to add the 0. This is one of the few exceptions, just to show that there's a number here. But if you didn't put the 0 in, it would still be fine. Okay, but this is showing that's the hundredths place. Okay.
Now, are you saying if we put 0.80, it'll be okay?
It's okay. There is this
That's where I get
tendency to do
confused. What
that.
do I?
Well, definitely if it was money. In a general problem, I would say throw this second 0 away. But when they wanted you to round it to 2 decimal places, I don't think it hurts to include the 0. So that's a little bit, it's a fine point and it's not a big deal.
So you always change the 0 to 1 if you're rounding?
This first one, in other words, the place
Yeah.
that you're rounding to, you make the decision based on the very next one. If it's 5 or more, the number in question goes up 1. So 0 would go up
Okay.
1.
It's always 1.
Always
Okay.
1 more. Yeah. Let me make up a different one.
So if it was 4,
So
it would
let's do
stay
this
4?
one. So let's round to the hundredth place. TH. Tenths, hundredths. Because this is the decision maker. And so it's the very next one after your place. And so it's not big enough. So the answer, you would keep it, the 6 would stay.
Right, okay.
On the other hand, if you have round to the hundredth, tenth, hundredth, this number is 5 or more, meaning that the hundredth, this number here, whatever it is, goes up 1. 9.43.
Oh.
Is that working?
Mm-hmm.
So if this number is 0, 1, 2, 3, 4, it would stay 42. But when it starts to be 5, 6, 7, 8, 9, it goes up 1 from here.
So you don't add the 7.
No, no.
Okay.
When they say they
That's
want it to
right.
100th
Okay.
place, this is the last place you're going to see a number. The question is that number going to be 42 or is it 43? And because of the
43, yeah.
7, it's going to be a 43.
So you just use that as a decision either.
This is
low
the
or
decision
stay the
maker.
same.
This is the one that will
higher.
either stay
Okay,
the
yeah.
same or go up. 1.
Okay, I got that.
Got that. Good job. Good
Yeah.
job. Okay, it's getting a little after. So here's my advice, and I'm gonna I think I'm gonna stop recording. Let me see if I can do that.